Hello and welcome to Tech Lessons with Alvin. Now, I'm really pumped for today's class. I won't lie to you. There's so much energy here because let me give you a little history. This is a topic that had me staring at the teacher in class like, yo, what are you saying? And I left the class believing this is a topic I'll never understand. I'll understand other topics in networking, cool. But when it comes to subnetting, this will be my Achilles heel. Like, nah, I don't think I'll ever get this. But to think I get it now, yo, I'm really hoping there's someone out there like me who believes Charlie Subnet in the end. Or probably you don't even know what it is and you have low expectations for yourself. Like, this one there, I just go watch, but I don't go understand. Opana, you understand. There's no overconfidence, but then with how simple the explanation is, I really truly hope that you understand. So without any further ado, let's get into it. Now, before we start, subnetting, of course, it's under networking. If you separate it into two, you get sub and netting. Sub as in submarine, underwater. Subnetting, it's under networking. You try to divide or find other networks from a main network. So I'll write something here and you don't really need to understand it, just need to look at it. And in the next video, which is the last video, you'll smile when you see it, like, okay, I get this. So what we're looking at here is 192.168.4.0, and then we put something here, a slash and a 24. What is this? Now, before we continue, this is not your basic mathematics, right? We are trying to divide this into other networks, cool. But we don't go ahead and use something like this divided by, let's say, 1/400, and then you put 4 networks here. If you put this in your calculator, decimal is supposed to be just 1 decimal point, but now you have pa. That tells you these are not decimal points, right? So what are we dealing with? If you can't divide it like basic arithmetic, how can you work your way around it then? Good question. Before I get to it, let's warm up. Let's warm up. I want you to think of this as bread. Now, don't leave. Please don't leave. I'm not joking. Really, think about bread. A nice, fresh loaf of bread. Now, in the olden days, if you wanted bread, here in Ghana, if you wanted to buy bread, you had to buy a loaf of bread. Even if what you needed was just a few slices, you buy the whole loaf, you take it home, you eat your few slices. If you are not fortunate and it spoils, well, you have to throw the rest of the bread away, right? But then something amazing was invented. Something called sliced bread. Wow. I don't know if you noticed. Now you go to the mall and stuff and then the bread is already sliced. It's so cool, isn't it? But then with networking, you, the network engineer, have to slice the bread yourself. That's subnetting. Now, picture this. You were able to get out of every loaf of bread exactly 32 slices. Now, why 32? We'll get to that in a bit. But you were able to get 32 slices. So someone comes and like, Charlie, I'll buy bread and give me some 4 cedis. You can gauge, okay, this 4 cedis give you about maybe 8 slices of bread, right? And so on and so forth. But as a rule of thumb, I don't know if that's even correct English. Generally, no one will sell the ends of the bread to you, right? It's not cool. It's not cool. Let's say you go and you just want 1 slice. They are obligated. It's an unspoken rule. They have to cut the bread, the slice, from the middle and give you that fresh portion, not the end, not the butt of the bread. It's not cool. So why all this? Why bread? Good. Let me clear this a bit. Hold on. Cool. Now, the ends I mentioned earlier, right? Think of them as Bad handwriting. But what I'm trying to write is, think of this end as the broadcast ID, and think of this side, I'm shortening it to N/W. That stands for network ID. Why network ID and broadcast ID? Because these two are not assigned to the host, right? The host will not have a broadcast ID or a network ID to have an address from this portion of the network, always, at all times. So when we get to solving, we'll find out what the network ID is and what the broadcast ID is. So because these two are not assigned to the host, what you normally do is, let's see, when you get your full number of number of IP addresses, let's say you get a number like 256, automatically you have to take away 2. So what you actually have to give to your hosts is 256 minus 2, which gives you 254. Now these are the assignable IP addresses. It goes on. If you have 32, you take away 2, you are able to give only 30 out. The other 2, like these parts of the bread, are not for the host. They are known as the broadcast and the network ID. Now, why the number 32? You've seen 32 here. Why is 32 here? Let me clear this a bit. Give me some time. Okay, I think we're good now. Now you have, get this out of the way. Get this, we don't need this. Now, it's 32 because of something special. Now, this right here translates into bits. Bits. You may have heard of them before. Now, some of you don't get bored, especially if you have some background in IT, right? It's always good to go back to our basics. Binary refers to numbers in ones and zeros, right? So what you're looking at here is just the number 2 in binary, right? Now, the number of bits in an IP address is the same as the number of slices in the bread here. It's 32. What this means is, if you divide these into 4, what you get here is 8 bits plus 8 bits plus 8 bits plus 8 bits. That's 8 times 4, 32 bits. Wow. Now we're getting closer to something. Now, how do we represent this as bits? Let me clear some space here so we get some work done. So now we have that information. Now you know this is 8, this is 8 bits, 8 bits, 8 bits. Okay, I'm looking at 32 bits. Now what is this? What is this? What is this /24? Excellent question. Now we need something known as the subnet mask to be able to divide this. Oh my god, I'm trying to draw an arrow, it's not working out. Anyway, to divide this into an address. So simply, what this 24 is telling you is you have 24 bits on, right? And 32 minus 24 is what? 8. So what that means is this last segment is untouched. So how will you represent this? Since it's a subnet, first 255 dot 255 dot 255 dot 0. 8 bits, 4, 8 bits, 4, 8 bits, 4, summing up to 24. Now this is where the subnetting takes place, right? This is what you really have to work with, right? Good. So what we need to know is, let me just give you a graphical representation, right? So if we are talking about 8 bits, this is it. 1, 2, 3, 4, 5, 6, 7, 8. Put your dot here. 1, 2, 3, 4, 5, 6, 7, 8. Put your dot here. 1, 2, 3, 4, 5, 6, 7, 8. Put your dot here. Then you do 0, 0, 0, 0, 4, 0, 0, 0, 0. This is it. This is it. It's just 24 ones and 8 zeros. This is where the subnetting takes place. So now you may be wondering, how many IP addresses can I get? How many IP addresses? Right? 192.168.4.0, and I have this /24 here. Okay, it's telling me that 24 bits are on, right? That means I have 24 ones. And then I have 8 zeros at the far right side, at the ending. Okay, I get this. And the total is supposed to be 32 bits. That's how come I have 8. 32 minus 4, 24. That's 8. Cool. So what next? What really does this mean? How many IP addresses will I have? Can I address to my client? Is it 8? Well, to get there, we need to do one more thing. Now, this is basic probability, right? Now, the reason I said this is basic probability, we'll find out right now. You have 1, 2, 3, 4, 5, 6, 7, 8. You have 8 bits. Now, I've not put any ones or zeros here yet. There's something important we need to know about these 8 bits. Before I put the numbers under them, I need to let you know how we are getting those numbers. Now, watch this space. I'll put a formula here, and by the time that formula enters this box, you'll understand what it means, what it does, how it works, and how you can use it. So, you've played the game before. Now, what game is this? You have a coin in one hand, right? Now, let's say instead of using normally your 2 fists to play this game, you decide to use just 1 fist, right? In so doing, the coin is either in the hand or it's not in the hand. It's that simple, right? What if you now use 2 hands, right? 2 hands, maybe this time 2 coins, but you get to choose how you put the coins in. Now, the possibilities become like this. It's either the coin is in one hand and not in the other, which in this case, the coin is in your left hand and not in your right hand, or the coin is in your right hand and not in your left hand, or you have 2 coins in both hands, or there's no coin in either of your hands. Now, you up it a bit to 3 coins. So in a sense, there's a third person, there's another person, right? So he just adds his fist. So now you have 3 fists looking at you. Now you have to choose which one has the coin, which one has the coin. It could be that all 3 have the coin. It could be that none of them have the coin. So how do you represent this as well? Now, it's either... Now I'll mess up this a bit. It's either none of them have the coin, or it's not in the first guy's hand, but the new guy's hand, it's inside there somewhere. Or it's not in this hand, but it's in this hand, and it's not in this hand. Or it's not in this hand, but there are 2 coins here. Or it's in this hand, but it's not here, and it's not here. Or It's here, but it's not here. And another one is here. Oh, it's here. It's here, but it's not here. Ah! You have all 3 coins in all 3 hands. Now, if you look carefully at it, you realize these are the only possibilities. There are no other possibilities, right? So, what are we looking at? What are we looking at? So, when we had 2 hands here, how many possibilities did we have? 4. When we moved on to 3 hands, how many? 1, 2, 3, 4, 5, 6, 7, 8. And when we had just 1 hand, we had 2. Now, are you noticing how it increases from 2 to 4 to 8? So the next one, can you guess? If your guess is it's like mine, then you have 16. You could take your time and then write it out 0, 0, 0, 0, 0, 0, 0, 1 in that order, and keep trying to exhaust all the possible options, and you realize that you have 16 of those possible options. Then if you move on to even trying 5 different combinations, you realize the 16 becomes 32, and it keeps increasing, it keeps growing. So now this is the formula. You have 2 to the power x. Get this right. Where x here simply refers to the number of, well, I almost said the number of hands, but we are dealing with networking. So the number of bits, right? So as a rule of thumb, we start counting from 0, right? So it's 0 to 7. So now with that analogy, analogy in mind, this x here just represents one of these bits, right? One of these bits. So let's put 2 to the power 0 here. We start counting from 0, right? Then we move on to 2 to the power 1, 2 to the power 2, 2 to the power 3. Sorry, my stylus pen is not really that good. 2 to the power 4, 2 to the power 5, 2 to the power 6, then 2 to the power 7. Now 2 to the power 0, we have a 1. To the power 1 is the same as 2. To the power 2 gives us a 4. To the power 3, an 8. And we keep going, 16. And we keep going, 32. And we keep going, 64. And we keep going, 128. Wow. And you realize, if you add up everything, all the numbers here from 122 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, you get 255. Now, I hope it's all connecting to you. It's all oh, okay, he wrote a subnet mask. Okay, he said that the slash 24 means 24 bits are on. Then he proceeded to draw 8 ones, 0.8 ones, 0.81, 0.8 zeros. Then he said when all the ones are full, it's 255.255.255.0. So okay, this 255 just means everything here is on. That's cool, isn't it? So now let me clear these ones. Now we get something. Now let's look at this number, 192. How can we represent 192 as binary using these 8 dashes we have here? What do? Now we need to find out the exact combination of numbers here that when added together will give us 192. And when we do find them, we have to represent them as ones, and the rest becomes zeros. Right? So let's try out. Now 182 was 128. 128 plus, let's see the next number, 64. I wish I could do something rough here, represent it so we all see. 128 plus 64 gives us, you have 12 here, 6, 7, 8, 9, and then a 1. That's exactly the number we're looking for. What this means is 128, this is the spot, you turn it on. 64, you turn it on. Now these are the only two we need to get 192. The rest, 0. It's not good, 0. Oh man, I don't like the zeros. Anyway, 0, 0, 0, 0, 0. So what does this mean? This just means 192 in binary is 11000000. Now we can try the same for 168 and 4. 4 will be easy because you just take the 4 here as on, just put the 1 here, and then everything else is 0. That's for the 4, right? And that's it. Now, how do we actually get the IP addresses? Before that will be the next video. So what have we learned? Looking at this, we have learned that this /24 here means 24 bits are turned on. Now, this also tells us that the total, which is 32, minus this 24 gives us an 8. And what this 8 simply means is in the last octet, we have 8 zeros. Right? And everything else is a 1. Right? Don't worry to count them. They may not be accurate, but you get the idea. So now we know how to represent this here. And even before this, what this also tells us, just looking at this, we are now experts. So what this also tells us is, /24. Okay, that means this side, this is what I'm dealing with. So the rest of them, I represent them as 255.255.255.0. It also tells us the subnet mask. So we can get the subnet mask and the representation of that subnet mask in binary. We can also now convert this exact IP address to binary. And in addition to that, we know how to convert it to binary using our formula 2 to the power x. What that simply means is 1, 2, 3, 4, 5, 6, each of 7, 8. Starting from the far right, you have the number 1. Next is 2, then 4, then 8, then 16, 32, 64, and then 1, 2, 8. So with this model, we can now translate any number we see in any of these octets to binary. Right? So now we have this idea. We understand what to do with the IP addresses. And what else do we know? This 1111111, these 8 ones simply tell us 255 possible IP addresses can be assigned. Right? And if you remember the bread illustration, we'll get to that in a bit. You get that, pun intended, in a bit. Anyway, with that, let me quickly chip this in. It's like how the clock works, okay? When it goes from 2:59, it doesn't go to 2:60, right? From 2:59, it goes to 3 o'clock. Same way, especially in an IP address, 192.168.4.256. What? No, it ends at 255, doesn't it? It does. What this simply means is it becomes 0, and just like in 259, the 2 now becomes 3, Once this becomes 0, you change what you have here to a 5, and it becomes 192.168.5.0. It's just like the concept of time, right? So out of the 255 possible IP addresses we can get from this particular example, we can only make use of 253. We took away 2. Now if you remember the bread illustration, the ends are not needed. The front and the back, those 2 slices, those 2, where can I draw bread? Well, let me take the top right corner, right? Yeah, it's a very small loaf of bread. But the point is, this and this part, people don't normally eat it, right? So you cut it off. So that's the same kind of mathematics we do here. We take away the broadcast ID and the network ID. That's why we take 2 away from the possible IP addresses. Now, I really hope you understand. I really hope you understand. I really hope you. If you understand, it will make me so happy. It will make me so happy. Really, I'll be really happy if you understand. But then, in the next lesson, I'll try to refresh what we did in a minute or less. It seems I talk a lot. In a minute or less. And then we move on to the actual stuff. Subnetting in its final form. So, it's been Tech Lessons with Alvin. This has been Subnetting Part 1. And I hope to see you in Subnetting Part 2. Have a great day. Hello, and welcome to Tech Lessons with Alvin. Now we're moving on to Subnetting Part 2. And you really need to watch the Part 1 to understand where we are right now. So without any further ado, let's get to business. So pick a familiar IP. We saw this in the previous video. 4.0/24. And looking at this, we understand. We know what we're looking at. Now comes the sweet part. It's sweet because it's easy now, right? I hope it's easy now. Now we have the perfect foundation, solid foundation. Nothing can shake can understand it. So what we're looking at, we can interpret it in so many ways. Excellent. So we need 3 network IDs from this, right? 3 whole new fresh networks from this. So how do we go about it? First, we can easily get our subnet mask from observing this section of our IP address. And what this section tells us is that we have 24 bits on, and we know the total is 32. That means it's leaving 8. So we will not write down all 24 ones this time, but we'll take note of the 8 zeros. Good. So these are the 8 zeros. And then we'll have some ones to the left. And so since you need 3 networks, how will you get them? Now, don't get confused. Honestly, once you realize how you get it, you realize, so this is subnetted. Really? Seriously, it will be so easy for you. Now, remember the whole exponent thing we were discussing earlier? How 2 to the power 0 gives us a 1, and then 2 to the power 1 gives us a 2. In that order, it keeps going and growing until we end it with the 1 to 8. You remember this whole thing? Now, this is basically what you use, right, to find or to divide your target network, which is this, into these 3 networks. So since you need 3, look here and find which number is closest to 3. You have 1 here, 1 won't be of much help. 1 won't be of much help. We don't have 3. We can't get 3 from 1. We have 2. 2 is close, but it's short of 1. It's not 3. We don't need it. Okay. We have 4. So we are going with 4. Right? We are going with 4. And what is 4? 4 is 2. Let me write it on this side instead. 4 is 2 to the power 2. Right? That's 4. So what this means is this 2 here is telling us how many steps forward we are to move. So now this becomes a new line. Now, what have I just done? Take note. This 24 means what? We have 24 ones. So if I go on to change this to a 1, and then I'm getting 2, 3, 4, 5, 6, 7 zeros attached to the 1, making a total of 8 bits. What happens now is, instead of having 24, now we have 25 ones. So it changes to a slash 25. I hope you're following me. Excellent. Excellent. So it changes to a slash 25. But with just this, we can't do much, can we? No, we can't do much. So in order to really get our 2 IPs, our 3 network IDs, take note, with this is either a 0 or a 1. We have only 2 options, so this is essentially equal to 2 to the power 1. But what we want is 4 IP addresses. So how about this instead? Right? So now we include 2 bits instead of 1, which translates to 1 1 0 0 0 0 0 0. Right? If you count it, you get 8. So this is better now. But since we've stepped into the last octet, and we've taken 2 bold steps into that new terrain, we add the 2 to the 24, and the new subnet here is 26. Excellent. Slash 26. Right? So how does this translate to 4 network IDs? Well, I know you know, but let me just write it down so you have a look at it. What happens now is you have 4 possible combinations. Remember, it's probability. And so you could have 0 0 or 0 1 or 1 0 or 1 1. Then you add your zeros. Right, make sure everything, the zeros add up to 8 because you're dealing with 8 bits. Right, good. So again, we have the binary notation, and in binary we have network ID 1, network ID 2, network ID 3, and network ID 4. So we can solve for them all and just pick 3 from the bunch. It's cool, isn't it? So how do we now convert? We have already solved the question, just so you know. We've already solved it. The only thing left now is to convert it, right? So if you remember, again, back to this, right? This is more like the backbone of subnetting. We need to know our powers of 2. So it will be really cool if you could keep this in your mind, get it off head. So before maybe you see a question having to do with subnetting, immediately scribble this somewhere at the top of a page or at the bottom. 1 2 4 8 16 32 64 and 1 2. You definitely need it. You keep revisiting that part of the page, right? Anyway, I talk too much. So remember, right, we have about 8 dashes, right? So what this basically means is, if you line it up to the powers of 2, on the far left, the very first number there, if you recall, is 128. Right after 128 is 64, and then it goes on and on. But since we are dealing with just 2, since we trapped, or in a way kidnapped or captured just 2 bits out of the last octet, let's just pick these 2 numbers. This is where a lot of our math will be coming in, right? Good. So what this translates to is 192.168.4.0. remember to put in your /26, and we discussed why it's /26. Alright, and then this 01 translates to 64, right? So you put in here 64/26, and then we move on to the next one, 1010. Okay, far left, very first number there, 1, that's 128. So it becomes 128/26, and now we have to add both 128 and 64 to give us 192/26. So your new network IDs become 192.168.4.0, 192.168.4.64, 192.168.4.128, and 192.168.4.192. That's it. That is subnetting. So it's like the cake. We have the cake. We have the cake, and the cake, it's nice, it's sweet. Oh my god, it's so delicious. But we need to decorate it a bit, the icing and everything. So now we need to get the hosts. The network ID, we have them already. We have the network IDs. We need to find the broadcast ID and then the hosts, right? So don't worry, we'll get to that in a second. So out of our 4 new network IDs, take note, the question only asked that we gave 3. So we'll end it at 192.168.4.128, right? .128. So what do we do now? 192.168.4.0. This is your first network. Your next network, you could be asked, right? What is the next network after your first network? You need to know that. That is this one, 64. So in solving for your first network, what do you think will be the broadcast ID? What will the broadcast ID be? Now, the broadcast ID is equal to this 64, right? The last number in your next network minus 1, right? So minus 1, that makes your broadcast ID 192.168.4.63, and this is already your network ID. So right now we just solve for 2 things. Now you have your broadcast ID, I had to shorten it to BID, and then this is your network ID. And one more thing you may have to show are the number of hosts. So starting from 192.168.4.1 all the way to 192.168.4.62. Why 62? You can't include the broadcast ID. Remember, they are like the edges, the ends of the bread, right? We don't need them. So .62. Now these are the usable IPs. So I can be a host in this network and have an IP address as 192.168.4.1, right? And someone else could have the IP address of 192.168.4.62, right? No one will have .63, no one will have .0, right? And you can apply this same technique to solving for the other two network IDs. So we could pick .64, knowing that the next network will be .128, right? So how do we solve for that? So automatically 192.168.4.64, that's your network ID. Since the next network is 192.168.4.128, you take 1 away from the 128 and you get 127. So that means 192.168.4.127 is your broadcast ID. Remember, your broadcast ID is the subtraction of 1 from the number in the last octet of your next ID, as we can clearly see in this example. So your broadcast ID for your 192.168.4.64 network becomes 192.168.4.127. That's 128 minus 1. So you have your network ID and your broadcast ID. Whatever is in the middle is your host ID. And what you are left with is 192.168.4.65 ending at 192.168.4.126. And you can use this same method to solve for the final network ID. That's it. So you can you can actually end it here if you get it, right? If you get it, you're like, okay, cool, I understand, thanks. You can end it and move on. If you could like or subscribe, that would be nice. But then you can end it and move on. But then for those like me who need a little more convincing, let's try to solve one more example. Just one more. So here once again we have a very familiar network, 192.168. Oh, 168.4.0. Right, this is /24 network. So looking at this, the question, right, is telling you we need 8 subnets. Now what are we doing? If you came here thinking, yo, I don't think we'll ever do, we'll never be able to understand this, you open up, you are subnetting. Take a moment to absorb it. Like, be proud of yourself. If you stuck with me from part 1 to this last part, you should be good in this, right? You should be good in this. I have high expectations for you. So please take a moment, just realize that you are subnetting, alright? Okay, so you can pause and do that because I'm going on. And so now we know how to translate this to an IP, right? I could just rattle the numbers, but then since you already know the formula, we leave this out, since the 24 is suggesting that we have 24 bits on, which means everything here is a 1 and everything here is a 0. So we have 8 zeros, Right, don't mind, don't even bother to count. I just did some scribbles there. So we need 8 subnets. So using our powers of 2, how can we get 8 subnets? Do we try 2 to the power 1? No, that will give us 2. Sorry for using this whole Dora the Explorer method. Should we do this? When the answer is so obvious. Okay, so obviously you don't use 2 to the power 1 or 2 to the power 2, but instead you go to 2 to the power 3, right? That's straightforward. It gives us an 8. So this 3 here tells us how many steps forward we are to move. And so we move 1, 2, 3. We draw a new line here. So take note, you are not just drawing the line, you are also adding up on the subnet here. Take note, this thing is called the CIDR, right? CIDR, classless interdomain routing, right? But don't worry about that. Just so we know the technical name for the /24s, right? It's the CIDR. Anyway, you add 3, the new 3 steps you took to this 24, and then the new subnet you'll be creating here is a /27. So after every network ID you discover, make sure you put your /27. So how many possible combinations can we get? Right? Of course, you can get your 0, 0, 0. You can get 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. You add it up, 3, 6, that's 8. Exactly the number of subnets we need. Now, at this point, you've already solved it, but then it has to make sense to someone. You will get it on, just by looking at it. You'll be able to continue and take further steps to answer the question. But now someone will need to know, what does this mean in numbers, right? So for that person's sake, we have to do some translation here. So this essentially translates to .0, right? This guy, take note. Now, you always need to get this down somewhere on your page. These numbers are really important. Always need to have them somewhere on the page when you're subnetting. Alright, and try and separate them with some lines. We need these guys. Right? Chemistry has the periodic table. Well, we have these guys. So have your dashes here. So in starting, remember, this is all from the right side. Sorry, from the left. This is all from the left side. So 0, 0, 0 is just 0. Now we come here, 0, 0, 1. So 132 is turned on. So this is .32. Sorry for the bad handwriting. 0, 1, 0, right? 64. This is .64. 0, 1, 1, right? That's 64 plus 32, which gives us 96, right? And 1, 0, 0, 1, 0, 0. So the 128 is turned on. We have that. You see how we are going? I'm sure you have already predicted everything else. Like, oh, this guy's going too slow. Hurry up. That's good. That's the goal. And from 128, we go where? 160, right? 128 plus 32 gives us 160. And from there, we go to 192, right? 128 plus 1 plus 64 gives us 192. And then finally, when you turn 128, 64, and 32 on, essentially adding all of them, you get 224. Right? Now let me try and clean a portion of this off. So we can take this a step further, right? Now this is all shorthand. Please don't do this. Don't do this, right? This is all shorthand. You have to write it out in full because of the kind of stylus pen I'm using, but you have to write it all in full. 192.168.4.0 is your first subnet, right? From this given target, right? This is your first. So you write it in full. 192.168.4.0. You do the same for the rest till you get to 192.168.4.0. Now these are your 8 network IDs, your 8 subnets. Now you need to show the hosts, right? The range. And I don't need to overstate this. You get it already. So I'll just rattle the first 3 with the confidence that you are following along. So with the first one, you have 192.168.4.1 to 192.168.4.30. And we know why it's 30 and not 31. Dot 31 is the broadcast ID. So dot 30 is the last host. So if we're starting from 32 as our second network ID, we go 192.168.4.33 to 192.168.4.62. And the last one, since I'm doing just 3 out loud, will be 192.168.4.65 to 192.168.4.94. So you now know how to find the broadcast ID. You now know how to find the network ID. You now know how to find the host range, and by extension, the number of hosts in every ID, in every subnet, right? Every subnet will have the same number of hosts. And how many hosts would that be? Can you guess? Remember, you have 30, right? It would have been 32, but you took 2 away from the 32, and you have 30. That's your host range, your network ID, your broadcast ID, the next network, right? You may be asked, okay, what's the network that comes after 192.168.4.96? And quickly you say, oh, okay, it's 192.168.4.128, right? So that's the next network. In a more practical setting, these subnets will be used to divide different departments in an office complex, right? So you have a nice office building with newly set up laptops, but then they will need to designate certain departments to certain IP address subnets, right? That's where you come in to save the day with your bird knife. Right? Now you have separated everyone into different networks. It makes things smoother and easier. Now, once again, please take a moment and just breathe in the new networking air, yeah, and just nod your head. If you can afford it, get a nice chill drink. I mean, water is a drink. You could get water if you have cold water. Or if you don't drink cold water, get something refreshing. Just celebrate a bit, because wow, this is not an easy thing to do, and you have done it. You have done it. Well done. You've made it this far, from part 1 to part 2, and I've shared a lot, and I really hope, I badly hope that you've learned a lot. Now it's been Tech Lessons with Alvin, where we discussed subnetting, and I hope to see you again in the next video.